Hi friends, today I have given you a homework on star delta transformation. So the numerical which you have to solve is winter 15, which was asked in question 2b for 6 marks. This is the given circuit which you have to solve by using star delta transformation, and in this circuit you have to find out the source current. So in this complete circuit you can find the different connections, but the best connection which I say is the star connection, which is named as, so you can represent this star connection with the nodes. So this is node 1. At this node you see the connections of this 4 ohm resistance, 2 ohm resistance, 4 ohm resistance and 3 ohm resistance. But which the star connection which we have to solve is, let us say this is node 1, the next is this node 2. Again at this node there are 3 elements connecting 3 ohms, 1 ohms and 2 ohms, and last is node 3, that is this one, where again you see the negative terminal of supply source, the 2 ohm, this 2 ohm and this 2 ohm is terminating. So this is node 3. So we have selected the star connection as node 1, node 2, node 3. So let us solve step 1. Convert star 412 into delta. What is that 412? This one, 412 connect is shown in a separate figure. Let us draw this 412 in this fashion, 412 in a star fashion. Let us represent its equivalent delta with a dotted line, connecting node 1 and 2 as R12, connecting node 2 and 3 with a dotted line R23, connecting 3 and 1 with a dotted line R31. So you have to transform this 412 star into its equivalent delta as R12, R23 and R31. That can be found out by using equation R12 is equal to R1 plus R2 plus R1 R2 upon R3. It means 4 plus 1 plus 4 into 1 upon 2. It gives you 7. Similar way you can find out R23 and R31. After getting these three values, you can draw this dotted line with a dark line so that it replaces 412 star into delta, which gives you the R12, that is 7 ohms, R23 3.5 ohms and R31 as 14 ohms. So this is the figure which is drawn in step 1 from the given figure 2b. Now step 2. Now you refer, this figure shows 2 and 14 is connected in parallel, 3.5 and 2 is also connected in parallel, and 3 and 7 is also connected in parallel. So solve that parallel combination. This parallel combination is 2 parallel 14, 3 parallel 7, 3.5 parallel 2. That gives you the values as 1.75, 2.1 and 1.273. Now from this step 2 you can draw a next figure which is shown here. So this figure shows, so replaces that complete parallel connection. So you get 2.1, the parallel combination of 7 and 3, then 1.273 parallel combination of 3.5 and 2, and this 1.75 parallel combination of 2 and 14. Now let us solve this circuit by simply series and parallel combination again, where you can use Ohm's law in step 3 to get the final value of source current, which can be written as voltage upon R equivalent. So this voltage upon R equivalent gives you the final value of the source current. So V upon R equivalent, say equation 1, where the voltage is known, which is 16 volts. So now R equivalent can be found by using, let us see this, let us trace the resistances connected. If we trace 2.1 and 1.273, we get that these two are connected in series. This series combination is connected in parallel with 1.75, and then this parallel combination, like the combination of these three elements, is in series with 4 ohms. So let us solve this and find the R equivalent. So the first series connection of 2.1 and 1.273, that shows the series combination, therefore it is in plus. then it is in parallel with the 1.75, therefore 1.75 parallel to this particular bracket. So that gives you the square bracket. That complete combination is in series with 4, therefore it is represented with the plus sign. So therefore finally you get this R equivalent as 5.15, and therefore from equation 1 you can get the source current, and that is the value as 3.1053 ampere. So this way you can solve this particular given numerical and the source current can be found out. There are different combinations that can be used to get the conversion, like this 4 to 2 connected in delta. So you can transform that delta into star, or 2 1 2 is connected in delta. You can solve that delta to star. Even 4 1 3 it is also connected in delta. You can solve that circuit by converting delta into star. But best way is to convert this 4 1 2 star into delta, so that you get the parallel combination and that can be solved. So this circuit can be solved in 3 steps. So final answer to this source current is 3.1053 amperes. So thank you so much. Bye bye.